Hello grade 9s, welcome to today's Maths Lit video lesson. I hope you're doing well. We're starting a new section today, the final section for Maths Lit. It's probability on page 296. So I know that you guys haven't really watched the videos on the previous section on data handling, and we'll hopefully cover more of that when we're back at school. But don't worry, because this is the last section. So we'll be recovering things for the remainder of the year. Make sure you are comfortable with all the material thus far. You might have seen examples of probability before. For example, weather predictions. They might say something like there's 60% chance of rain, and they will come up with the stat based on past history. They might look at the geographic location, rainfall, season, etc., and are able to say that on 60% of the days like this one, it rained. So another example that's common is the COVID-19 relating to recovery statistics. They say that approximately 4% of all people who contract the illness will die. And they get this stat as well based on past history, the stats that happened in China where the disease originated, and then they get further information as the disease is spread globally across different countries, across different types of people. How do we represent probability? We either use a fraction or a percentage. So I've put down our probability scale over here. 0 corresponds to 0%. A half corresponds to 50%, and 1 corresponds to 100%. So what do these numbers on the scale represent? 0% represents an event that's impossible to occur. For example, Wolves winning the Premier League, they just don't have enough points. A certain event would be something like the sunrise, guaranteed to occur the next day. In between, we have the 50-50 chance, 50%, that would be something like a coin flip. So a coin has two faces, and if we want to predict a heads, it's one out of the two faces. We can look at a similar example related to this. If we're rolling a dice has 6 faces, and if we want the probability of getting a 6, this would be one of the faces, the face with the 6, divided by the 6 possibilities. And if we look at where this lies on our probability scale, 1/6 would be below a half. Next, I want to go over the concept of theoretical probability as opposed to experimental probability. Theoretical probability is based on a mathematical model. So for example, we have our coin flip, and we know that there are 2 faces and that this coin is balanced. So when it falls, it has an equal chance of landing on either of the faces. In certain old school casinos, they would rig some of the games, and with a coin flip, for example, they would make one of the sides heavier than the other so that there was more chance of it landing on that face. So for a fair coin, a balanced coin, the chance of getting a heads is 1 out of 2. Let's look at a similar example. Here we have a shuffled pack of 52 cards. It's all mixed up. You can randomly select any card. It doesn't matter. It's all spread out. So the probability of drawing an ace from a pack of 52 cards is 4 out of 52, because there are 4 aces in a pack: the ace of hearts, the ace of diamonds, the ace of clubs, and the ace of spades. So here as well, by shuffling the pack, we are assuming that it's a fair draw. Next, we'll talk about experimental probability, and unlike theoretical probability, which was determined from a mathematical model, experimental probability is determined from experience. So once again, we'll look at the example of our coin flip. And how we go about this is we would flip the coin 100 or 200 times, as many times as possible, and we'd count the number of heads and the number of tails that we get. So say we flip this coin 1,000 times, and we got 502 heads and 498 tails. So 502 out of 1,000 was heads, and 498 out of 1,000 was tails. So once we've gotten these results, we can look at them and say, it looks like heads and tails occurs roughly 50-50 times. So our experimental results are used as an estimate for our theoretical results. So this is how they would test in these dodgy casinos mentioned earlier, whether the coins were biased or not. You would flip it maybe 1,000 times, see that there's way too many heads, maybe 60% or 600 out of the 1,000 were heads, and you can conclusively say that this is biased. Next up, I want to go through the two worked examples on page 296 and 297. For the worked example on page 296, we have a problem that asks, what is the probability of getting an even number when you roll a dice? So what numbers could we get when we roll the dice? We could get 1, 2, 3, 4, 5, or 6. And the even numbers are 2, 4, and 6. So 3 out of the 6 numbers are even. So the probability of getting an even number is 3 out of 6. The next worked example deals with experimental probability. In this example, 500 bottles from a factory are chosen at random, and it's found that 25 of them are cracked. So this experimental probability is going to be used as our theoretical probability for determining if a bottle is cracked or not. So probability of being cracked equals 25 out of 100. The next part of the question asks us to find the probability of a bottle not being cracked. So if out of the 500, 25 were cracked, it must mean that the remaining 475 were not cracked. So the probability of not being cracked is the 475 out of the 500. Lastly, I wanted to go over some of the problems from exercise 25.1 on page 297. I'm just going to be going over questions 1, 4, and 5. For the first question, it asks us to write the following as decimal fractions and also as percentages. 1a is asking for the probability of getting ahead if you toss a fair coin. We know that as a fraction it's equal to a half, and that is the same as 50%. As a decimal fraction, it's 0.5. Just to refresh, how do we work out percentages from the fractions? We just take the fraction and times it by 100. To get the decimal points, we just plug this into the calculator and it should give us this number in decimals. Let's go on to the next part. Question 1b. is the probability that the moon is made out of cheese. So that is a 0% chance. It's impossible. And 1C is the probability that you are reading this. That is 100%. So that's 0. Sorry, I forgot to put the percentages. 0 is 0%. And as a decimal fraction, it's just 0.0. 1C, the probability that you're reading this is 100. And in terms of decimals, it will be the number 1. Let's go on to question 4. One fair 6-sided dice is thrown. You don't have to get 6-sided dice. You don't have to get cubes. You can get all kinds of different die with different numbers of sides. You get a triangle shaped dice with 4 faces. You might get a soccer ball type die with many faces. So here we have a 6-sided dice. What is the probability of getting 5 or more? Once again, when we roll a 6-sided dice, we can get the numbers 1, 2, 3, 4, 5, or 6. And the probability of getting 5 or more is either if we roll a 5 or a 6. So that's 2 out of the 6 possibilities. And we can simplify this fraction if we want to a third. In percentages, this would be 33,33. In decimals, it's 0,33 recurring. Lastly, we're going to look at question 5. You buy a ticket in a competition where there are 500 tickets numbered 1 to 500. Every ticket that has a number ending in 0 will win a prize. What is the probability that you will win a prize? So out of the 500 tickets numbered 1 to 500, how many of them end in a 0? I've listed some numbers here from 0 to 100. Sorry, it starts from 1 to 500. So it's starting from 1 to 100. And the numbers ending in a 0 in this range are 10, 20, 30, 40, up to 100. Similarly, for the range 101 to 200, we have 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. So if we continue in this way, we can see that in the range 1 to 100, there are 10 numbers ending in 0. In the range 101 to 200, there are 10 numbers. So it's 10, 10, 10, all the way up to 500. So the number of tickets ending in a 0, it's going to be 5 times 10, 5 batches of 100 from 1 to 100. 1 to 500, so it's 5 times 10, which equals to 50, and the probability of ending in a 0 is 50 out of 500, and we can simplify this down to 1 out of 10. If we take this fraction and times it by 100, we get the percentage, which is 10%. And 1 out of 10 on the calculator is 0,1 in decimals. So that concludes today's video lesson. I hope you guys understood, and I look forward to seeing you guys coming back tomorrow. I know that Aura is still doing homeschooling potentially, so we'll continue the video lessons with him. And yeah, no homework for this section. We'll pick up when I see you guys. Thanks for watching and take care.